Thank you. Right. So today I'm going to introduce the software that we've written to support the coursework, which we're calling Ubiq. Ubiq is a framework for building social VR applications. It takes care of mainly messaging, as well as implementing basic services that you'd be familiar with from other social VR apps, such as audio chat, avatars, room management, and the like. The software takes the form of predominantly a Unity package, which will deliver on Moodle that you import into your project, a server at UCL that we run, and a set of examples showing you how to implement or use some of these basic features. Now, if there are any questions while I talk, I'm going to swap between actually the Unity editor and PowerPoint a lot. So can I ask some of the other TAs, if you're around, if you post questions in the chat as we go, and then they can interrupt me and yell them out, and I can either answer them as we're doing it or pin them to the end. So feel free to post questions in the chat.
Dan, can you be in charge of that, please?
Yep, sure.
Okay, so there's a bit of a introduction. Functionality-wise, in its current state, Ubiq is, I must say, ever so slightly less capable than platforms that hopefully you've experimented with, like Rec Room, AltSpace, or Spatial. The problems that it's designed to solve are ones that are not being and likely never will be addressed by any commercial platform. And those are, firstly, remote code execution. So when you design your own applications, your own experiences, you want to be able to script, and that script to run on other players' machines. Typically, that is not supported by any social VR platform we're aware of easily. Our system, Ubiq, is also able to work without sending data to third-party servers. This is typically done, say, in systems like Photon, where for audio chat you need to use a relay server that you don't know the location of, you don't know who owns it. That presents a problem.
Just to interrupt, sorry, are you supposed to be showing slides? We've had someone ask.
No, sorry. Okay. I am going to show slides later. This is just a
okay, great.
introduction. It will be just text. I'll just list it. I'll tell you what, you can see the slide. In fact, that would be a good test, wouldn't it? Let me just check if I can actually share my screen. I want to share the entirety of screen one. There we go. Yeah, so we don't send data over third-party servers. That's quite important if you're doing experiments for data protection issues. We don't have accounts yet, and even if we did, they would be managed entirely internally because, simply put, asking you to sign up for third-party accounts as a necessary step to do your coursework is unethical. And finally, most importantly, it's open source. You get the full source code, including that to the server. We'll put that on Moodle, so you can see how every single piece of functionality is implemented, all the way down from the networking APIs in the OS, all the way up to the user interface. So that's a brief introduction of what we've built. And now I'm going to drop out into Unity, and we're going to go through a brief introduction so you can actually see it and see what you can expect. This Unity project, what you will get after you import the package should look almost identical to this. I have the development checkout, so the architecture at the top level might be ever so slightly different, but you will have this samples directory. And in samples, in introduction, there is a scene called Hello World. This is the most important scene in the application. It serves as both a collection of pretty much of all the functionalities represented here. In examples, it serves as a teaching room and also as the launching pad, because you can go from this room to other rooms via this menu. So I'm not going to go through the hierarchy just now. I'm instead going to jump right in, and I think Felix is standing by to be my counterpart in VR. Are you ready, Felix? If you are, you're muted.
Well, that's probably better.
Thank you.
Yes,
Okay.
I'm here.
So we have in Ubiq a desktop and VR interface. So Felix is going to go into VR in the Quest with QuestLink. I'm going to stay on the desktop so that I can share my screen and you can see everything properly. You can actually see the editor as I'm driving it. Now, to swap between VR and the desktop, you should go into the XR plugin management and just toggle this option here. That effectively tells Unity to start the VR system as soon as you enter play or you execute the binary if you've built it. In theory, this XR plugin management should allow you to swap between turning VR on and off at runtime in Unity. We find it's not that reliable. So while I have put a little button here to turn on XR while you're in play mode or while you've executed, it tends not to work that well. So it's build settings, player settings, and hit that toggle under XR plugin management. It only takes a minute to change between the two. So I'm going to stay in, am I going to stay in? Yes, I'm going to stay in desktop mode. I'm going to press play. I'm going to drop myself immediately into this Hello Room world. So I can look around by holding the right mouse button. I can walk with WSAD, strafe around, and I can interact with objects as well. I can interact with the UI by clicking as normal. With this screen share, you can see my cursor, right?
Yes.
Yep.
Yes, thank you. Yeah, so you can see my cursor. I can interact with the UI. I can interact with objects in the world too. So I can, if I middle mouse click on objects, I can grasp them and use the scroll wheel to move them around, hold the right mouse button to move the object, can push it out, and then I can click the middle mouse button anywhere else other than on the object to drop it. So I'm going to click, if I click on the object, it changes where I'm holding it. So watch out for that one. And I can use objects as well. So I go up to the object, actually drop the object and click on it. So I'm clicking with the cursor, not with the ray that represents the where you'll be pointing if you were in VR looking at the UI, or the hand that just represents where the physical manifestation of your hand is. I'm interacting with the cursor, click it and click again, and I can use objects. So the next thing I want to do in this room is I've connected to the server by default to UCL, but there are no rooms. I'm not in a room yet. I'm just in my own local lobby. So I'm going to create a room by clicking this plus sign here, and there's my room. I've already joined it. I can see I've joined it because in the editor, if I click on network scene, I can see I've joined room 0, and I can also see it in the console. I'll print out a little message. So now Felix can press play in VR, and he will see an environment much like this, but when he presses join, he should appear right next to me.
Other way around, Sebastian.
Ah, hello Felix. And you see, this is Felix's avatar. I have an avatar too. His is fully articulated though, because his is tracked with his full VR rig. And now we can move around this environment. I don't know if you can hear, but there's also audio chat with me and Felix, so I can speak to him through the VR system and he can speak to me too. And so we can interact. I can say, spawn objects, grab them, and hand them over to Felix. And we can both spawn fireworks, and well, I can't shoot them at Felix because I'm on a desktop environment, but he can very happily shoot them at me. The fireworks don't despawn. I will tell you that now. So those particle effects will go on forever and ever, and you can instantiate as many as you like through the box. What you do with that information is up to you. So, and I can also change the environment. Felix will follow me through.
Yeah.
Okay, so that's about the state of play as it is now. So I can also actually, I'll show you, I can leave this room, jump back in, and that room will persist as long as Felix is in it as well. And so now I see the room, I can hit join, and there he is, where I left him. Okay, thank you, Felix. So I'm going to drop out of this. I'll probably show you the different options for creating rooms later on, actually. So let's go back to the slideshow. So that's what it does. It has the state of play right now. So let's talk about how it works a little bit. There are two main parts to Ubiq. There's the messaging layer, which actually performs all the networking and message exchange. And there is the services we built on top of this. And the services are what you would know as social VR features, the avatars, the room management, audio chat, object spawning, so on and so forth. The messaging layer is responsible for allowing components to talk to each other. And so we're just going to do a brief introduction to both of these, starting with the messaging layer, very high level, and we can go into more detail later in smaller groups or during the lab sessions. So the messaging layer is built to interact, it's built to work very well or even mimic the Unity component-based programming model. So I'll just do a brief refresher on that. So hopefully you remember much of this from the Unity tutorials. Unity has a component-based or composition-based model to building virtual objects. What that means is that... Pardon? Say again? Is there a question?
No, I think that was accidental.
Okay, no problem. If there isn't a question, remember, please post them in the chat and Dan will yell them out. Okay, so Unity has a composition-based programming model, and what that means is that instead of, say, if I wanted to make this the typical example of a torch, instead of me in code creating a new torch class and then writing a bunch of code that submits draw calls to draw it to the screen, sends instructions to the audio device, draws the particles, and so on and so forth, what I do is I start with this common type, this game object, and I build up my virtual item by adding components that are very self-contained and very only loosely coupled. So these can have direct references to each other. For example, I might, if I build up my torch like I show here, I have my, say, this common type that's reusable across Unity. Then I make it a torch by adding a torch shape mesh that draws this to the screen so I can see it. Then I add a light source. This actually is responsible for casting light into the environment so that I can see the effects of the torch. Then I might have a particle system so that I can see my virtual fire itself. Then an audio source for the crackling. And if I want to modify this object in some way, I would use, in my own scripts, I would get references, direct references to these other components and use their APIs to control it. So say I had a torch, I cast a spell and I want to turn the orange fire into blue. I write a script, a very short script, self-contained, that gets the light, the reference to the light component, modifies it, modifies the particle system as well to change the color. And that's effectively how I build and I modify my virtual objects. Now that's fine if you are on one machine, but what happens if I have, say, two players? So here I have player one on one computer and player two on another. Now player one is fine, works as normal. I give my user input, that should change the color of the torch. So my script gets a reference to the light, changes the color, fine. Player two, though, cannot directly reference this light, or I cannot directly reference player two's light because this is on a separate computer. It has a completely different memory space. It has no ability to see what player two is doing. It's a black box effectively. In order that player two sees changes to my world as they happen, I need to communicate in some way to player two. And this is effectively inter-process communication. Networked VR is effectively a subset of inter-process communication. It's how you get processes in different memory spaces, either on the same computer or others, talking to each other to keep themselves in sync in some way. And the way I do that is I send messages. So this script itself is now aware of its own existence as a networked object. So it will have functionality. It's still going to talk to the light source, this component here, and change the light when I give my user input, but it also knows that it has to send a message to player two to tell player two to do the same thing. So it sends like a color change message off to player two receives it, player two gets a direct reference to its own light source, makes that change, and there's my light. It changes to the correct color. Now, this message passing process here, the exchange of messages, is the job of the networking system. What goes in the messages is up to you as the developer. And so that's what you're going to build. Now our messaging layer is designed to operate with Unity's component-based systems. And it's designed
sorry to interrupt. I've just got a question. Is this client server-based, so the script will send updates to the server or to all players?
That's a good question. The answer is a bit of both. So let me take this by bit. Is it client server based? Yes. We have a server that the messaging layer will talk to. And the reason we have a server is because you need a central authority to do things like room management. So when you go to the server, only the server creates or lets you join rooms. So that part is client server based. Is the messaging layer client server based? That bit is no, it doesn't have to be. The messaging layer, if you create the correct connections underneath, the messaging layer will do P2P. We don't have any example of our code that does that yet. Everything is reflected by the server for now. The audio chat is P2P, but that's managed by a native library that we write. So I guess in answer to your question, when you're coding, will your messages go via the server? Yes, but if you really want to do P2P connectivity, it is possible to do that in what we provide. Hopefully that's clear. If there's if you need further clarification, just let me know and I'll expand on that. Okay, so messaging. So it's a component-based messaging system that works with Unity's objects. So the messaging layer, rather than say have a single message processing function where all messages go to one point in the program and you have this monolithic function that splits them out, our messaging layer will hand off messages to particular components. So in this example, I have two torches and a door in my scene. Note that I have the torch color controller. This same script is applied to two separate game objects, but the messaging layer will deliver the correct message to the correct counterpart of that instance. So although these are the same types, they are separate instances of this script, and messages go to the correct instance. So the messaging layer takes in messages that you define from your components. It takes some instructions to build the actual connections using the operating system's networking API. So it will make TCP connections to the server or to other peers. And it will then perform the interchange between these. We'll take messages, push them out over TCP, we'll see where they're meant to go and deliver them correctly. Note that not all objects are network enabled. So this audio source here, these are Unity classes, they know nothing about the network or the messaging layer. The only way that these are modified by the network is if you do so using your messages. So I send a message that tells this instance to go to its audio source and do something, right? And I send that message, that goes through here. This one gets a direct reference to the audio source, updates it.
Got another question for you. How is state consistency preserved? For example, if you were to grab an object and another player grabs the same object before receiving the message?
Good question. Right. We don't specify that. It is up to you because it really depends on how you want the physics model to work. There are a bunch of different ways to do network physics, and I'm going to avoid getting into the weeds of that because I'll talk about it for a very long time. This is one of my pet areas. There are the examples in there do this in some different ways. So, for example, the firework that is owned by the peer that creates it. So if I create the firework and set it off, Felix will see the firework that I create, but Felix can't do anything to it because I'll just keep pushing messages to Felix's firework and the code is written. Yes, let me continue. I'll answer that question because we're going to look at an example next, but let me just continue. So that's one way to do it, that's what's called a level 1 collaboration where I can effectively see you. I know you're there. Level 2 collaboration is manipulating the same object but at different times, or manipulating 2 degrees of freedom of the same object simultaneously, but 2 separate orthogonal degrees of freedom. This would be where, for example, the basketball example. I grab the basketball and I'm moving it around. Now my physics engine is responsible for the basketball and Felix just sees the results. Felix can come to the basketball and grab it off me, at which point Felix's physics engine is now responsible for that. His process controls where it is, and he sends me messages telling me where I'm to draw the basketball. How that handover is done, that's up to you. This code is very simple. If you grab it, it just sets a flag, and the processes argue about a flag. We can actually show you a bit funny, like an odd artifact of that happening, if you like, at the end, if you're interested. A level 3 collaboration is multiple people manipulating the same degree of freedom at the same time. This is the most complicated one, and one that is kind of the like the holy grail of a manipulatable world in VR. How you do this, there are different ways. One is force reflection, where you have somebody who in theory owns the object, but instead of them just only giving their own input to it, you send in, so say I owned the object. My physics engine controls it, but I receive force inputs from a remote peer. So Felix sends a force, maybe based on a spring constraint, and my physics engine will integrate it. So although I control where the object is, in theory, Felix can manipulate it. And if it works really well, then we have level 3 interaction because we can both move it together. That has some downsides. Another way is to do a constraint-based resolution. So I simply say, I want the ball here. Felix says he wants the ball here. Both our machines have copies of these constraints, and then we have a system that works out where it should be, and hopefully we come to the same conclusion. So there are different ways to do it. This system doesn't specify any particular one. All the system does is message passing. So that's up for you to decide, and it will change depending on objects. Some objects will be more suitable for level 1, some for level 2, and some for level 3 as well. So let's have a look at a level 1 actually, and go back to the firework example, and I can show you how exactly you would implement a network object. So in my scene, I have this fireworks box, and the fireworks box allows me to instantiate this prefab. So this is my firework prefab. As I said, component based. I have a rigid body for physics. I have some colliders. I have particle effects and the like. And at the top, I have a script. And this script implements all of both the behavior of the firework. So it adds forces to the rigid body, it turns the particle effects on and off depending on the state, and it performs the network the network functionality. I know it's network enabled because it subclasses from an interface called iNetwork component, and that implements a callback. This script is for medium length, but there are only 3 bits that we're interested in looking at that are to do with the network. That's this line here, line 43, network scene register. Line 71, send JSON, and this little block down here, process message. What this script does is we start off in the start method by registering this object. And what that means is it's telling the network that it is a network enabled object and it wants to receive messages. So I say I exist, like this is like the equivalent of the awake function for the network system. I pass it in and say I now exist on the network. Once this is called, this component will receive messages if somebody sends it some via this callback here. As soon as that happens, that's it. Once you call that, you will receive messages. There's nothing else to do. The other thing this can do is use this object returned by this. So this little context object is a little helper. It'll tell you things about your existence on the network, your identity or address, and also allow you to send messages off onto the network. And that's pretty much what I do. So if I'm the owner, so I spawn the object, so my physics engine controls it, Felix just looks at it. On every frame, I generate a message and send it out onto the network. So that message is that one there. That's it. That's what I'm sending at this point. And all it contains is the transform of the firework and whether or not it's lit. Now on Felix's side, he will receive that message and his code will pass the message and update his representation of the firework, as well as flagging whether it's fired or not, which controls the particle system. And that's it. So that is a network-enabled object. That's how this simple example synchronizes across the network. No more complicated than that. Let's go back to, okay. Now, back to the second part of that question I got a couple of slides ago. Client server based, one of the questions was, what happens if you have multiple peers? The messaging layer handles that for you. So in my example with Felix, it's just been me and him, but you might have multiple players. In that case, the messaging layer is responsible for fan in and fan out of messages. So if there are multiple players with multiple instances of that firework, with that firework script component on it, this will transmit it. This will do the fan out. Notice that in this code, the firework doesn't know anything about other peers. It just sends one message, and all of the other instances of this component will receive that same message here.
Got another question for you. If an object is instantiated in one scene, will it automatically be instantiated in the other? How do you deal with object creation?
Creation. Okay, this I'm going to put a pin in this one because it's relevant to something we're going to discuss in about 2 or 3 slides when we discuss rooms versus scenes. It's a good question. We will come on to that very shortly. Okay, so we do the fan out, and that's it. Okay, so that's the messaging layer. Now let me talk a bit about some of the services. So we've coded a number of services or features, and I'm not going to go into all of them in great detail because it's not really necessary at this point and limited on time. But I'm going to point out a few things that I think it's important to pick out that might catch you out if you're not aware of them. So before we begin, notice how that fireworks script didn't just not know the number of peers that were available. It didn't really know anything else about the the environment otherwise. It didn't know, for example, anything about avatars or like which hand it was held. It didn't know anything about which room it was in. It just talked directly with the messaging layer. The services that we have, all the services have a one-way dependency to the messaging layer, and all of them are optional. The messaging layer talks to the networking APIs as soon as you send the instructions to create a connection between two messaging layer instances or the like. Where's my diagram? Oh. As soon as you've made this connection, this TCP connection, these are ready to exchange messages from components. So if you wanted, you could instruct this to make a TCP connection to a static endpoint or endpoints, hard code all your object IDs, and you could build a functional social VR system. So the dependencies are one way. These services are all built on top of this messaging layer. So you don't need, for example, a room to exchange messages. So much of your code that you will write will interact with all three layers. So you will use our services, you'll use the messaging layer directly as the file did, and you'll also, of course, talk to Unity itself. And a lot of your code will operate in parallel to what we have written. You might even write your own mini services to run on to support some other bit of your application in order to support some particular interaction mechanic that you particularly want to build. So let me talk a bit about some of the services that you might want to know about. Right, so room and scene, and object persistence. Rooms and scenes are separate. This is something to really bear in mind. The room really is, as a concept, is not much more than the people that you are playing with. There's a very little bit of metadata that you get stored with a room, but that's about it. The scene is an actual Unity.scene file and contains all the scripts and the prefabs and everything else. There is a very, very weak connection or dependency between the Unity scene and the metadata, because this metadata object can contain the name of a scene to load. That's how I was able to swap the scene around when I was playing with Felix, but that's it. The room is concerned with who you are exchanging messages with. The scene is concerned with what components are in the scene to exchange messages. So I can swap the Unity scene around my room, and if I change the scene, it doesn't necessarily change the room. So to answer object persistence, okay. If in fact, let's do, how long have we got? 20. I think we have time to do a quick demonstration with Felix. Yeah, Felix, are you still there?
I am.
Great. Let's just do a little scene demonstration. So I'm going to come into Hello World, and I'm not going to join a room. So Felix is going to go to the. So if I create a room, sorry, firstly, Felix should see room 0. Do you see room 0 with the Hello World background, Felix?
1 second. Yes.
Okay. So now Felix is going to create a room. Now I see, okay, and Felix has gone to the apartment. See, Felix read my mind. Okay, so what Felix has done is he's gone into his scene, clicked on the apartment button, which changes the room, and notice how the room that I created has the apartment. If I go to Hello World, the room scene, my room has changed back to Hello World. And if I join Felix's, oh sorry, I'm not going to join it because I'm in Hello World. Okay, let me try that. There we go. And there's oh no, come back. Oh, this game. There we go. And I've joined Felix's room again. Hello, Felix. I should point out, okay, another thing about rooms and scenes, there's no explicit functionality to exit a room, so I shouldn't really have done that. The way you exit a room is you exit play mode. There's a reason for that. The reason is that exiting a room involves tearing down a lot of resources, and it's not, really necessary for. Where's Felix? Oh, I've joined no room. Anyway, I'm getting distracted. There are two ways to create a room and have a scene set. So in the first instance, I'm going to create a room and I'm going to set the scene by modifying it. So I'm in our room 2 and I've created the apartment. Or I can exit play mode. I can start in a new scene. You need to catch up. I can start in a new scene and then I can create a room. If I were to start in, say, a new Unity scene, I were to just drop the network prefab in here, I can join a new room. I can create a new room using that menu. And for interest's sake, the UI and everything is in here. So I do have my rooms menu located. If I don't have the scene in the directory of available scenes, it just won't do anything. And what that means is that you don't really need to use this menu system to change your scene. If I create a new scene, a new Unity scene with a network prefab, and I create a room, and then the people in your team or my team, they go off, they do the same thing, we will end up in the same room, in the same scene, and our scene's components will talk to each other. So you can go through this, but you don't have to. And this scene manager object is very simple. Right here is the actual hierarchy for these buttons. This is that's just a string, and it just refers to the name of the scene in the Unity build settings. And it will find that and load it in the background. And so it's just a bit of metadata. Now, in terms of object persistence, because the scene is just a room, sorry, because the room is just a bunch of metadata on who you're talking with and is not the scene itself, anything you create under the network scene instance will persist. So the scene is just, if you like it, you can almost think of it as another prefab that you instantiate, just that Unity handles scenes and whole hierarchies prefab ever so slightly differently. But it's a very similar concept. So in terms of doing consistency, the object spawner as we've created it doesn't have that inbuilt. So if you want to have objects that, if you want to, for example, spawn an object and somebody else joins, they see the object, all the existing objects created, you have to have some sort of bookkeeping system where that will happen for you. You could put it into the room metadata if you like. There's examples of, say, the room images that will show you how to do that. So as an example, oh, that's not the right scene. Felix, are you in a room at the moment?
Yes, I am.
Which one are you in?
I have no idea.
I guess there you are. Okay, so now if I spawn a basketball and now I change my scene back to Hello World, you see the basketball is still there. So, and if I leave and rejoin the Hello World room, Felix will see the basketball, but I don't see the basketball because that has not been generated in my local hierarchy, because the object, the network spawner doesn't do that at present. Okay, so that's rooms and scenes. Let's have other things you should know. Right. Cross-project play. Not supported at this time, and by that I mean if I'm developing with my team, we're probably going to have the same code. We're going to have the same game assets and scripts and messages and the like. If I'm on team A and I want team B, I've just implemented this cool thing. Someone from team B who I'm friends with, I want to try it. If they want to play, to see this, I have to give them a copy of my project. Well, fine, you can do that. It's just you might expect that if I build something, the network system will deliver it to the remote player when I go into their scene. It doesn't do that. There is a way, it is technically supported in Unity, and the solution is asset bundles. And asset bundles are a method of packaging up assets along with all their dependencies into a file that you can distribute, and you can load it at runtime, and you can load things that the build of Unity has not seen before. We're not suggesting you use this for this project, and the reason is that they are a bit fiddly. You have to know Unity quite well to make them work. And so while it would kind of be nice to have, it's probably more work than it's worth, because the majority of the work will be working with a team and you'll all have a copy of the project. And at the end of the module, we have to collect the source for the projects anyway. So although it's going to be a little annoying for us to have to manage sort of 15 full Unity project directories, that is like the worst, that's the worst part of it. And so it isn't really worth trying to support asset bundles. But know that that is a solution out there for after this module's over, should you want to do something like that. Okay, object spawning. It exists. You've seen it. It's not persistent. If you want to make it persistent, you basically want some sort of find somewhere to store it, be it in the scene metadata or some sort of shared object that gets passed around and is locked. There's a network spawner here. If anyone wants to understand how that works in more detail, that's for the user interaction. Don't care about that. That's the bit that spawns the object. Right. Avatars. We have avatars, you've seen. They are customizable, both in terms of the actual avatar shape itself, along with the skins. At the moment, we have Ben's the avatar master, so we have his default avatar is loaded up at the moment. We'll expose the functionality to customize the avatars and the textures to send them out. It's just not in the current version. Okay. Audio chat. Audio chat's based on WebRTC. This is the media stack that is built into all modern browsers and the bane of my existence. Things to note about the audio chat is it's not yet spatialized. I just want to point that out just in case any of you were thinking about the mechanics. Do be aware of that. And also to say, the fact that it is not spatialized yet does not mean that we don't think spatialized audio is important. In VR, it's super, super important. Audio is really important for the complete experience in virtual reality, and a social VR system should have spatialized audio. It's just not in there in this current version. Hopefully it will be there very soon. But do bear that in mind if you're thinking about mechanics using audio. And something that applies to every form of communication in the CVE is really, remember that when you're developing, don't rely on the communication. The communication to support your game mechanics. When you're developing, use secondary channels. Like Felix and I are talking over Zoom while we're doing this, because you're going to be jumping in and out all the time. Okay, and that's it for the introduction. So let me quickly go through the next step. So this week's tasks, lab tasks are download the code, and your job is to create one or more additional fireworks and add them to the box and make it select them randomly. So you have to go and make another one or multiple ones of this prefab and modify this asset to randomly select a firework and create that appropriate firework at the remote end and send messages. So create more prefabs with different functionality than what we've coded. In generally speaking, you should not modify anything that we put in the package, either code or prefabs, because we'll push many, many updates. So subclassing our code is good, that's encouraged. Modifying it is not. In this example, go ahead and modify this script or make another script to modify the prefab. That's fine for this 1 week. This is very simple. You can just copy that. That's all it does. So you can make a new prefab out of that. Okay,
Got a question. How do we update your code?
How do
Just
you update the
replace
code?
it with a new one, or is there something fancy?
Felix is going to talk about that very quickly. If I just run, I'm going to go through my last slide and then hand it over in the last few minutes. Okay, so support is via Moodle and email. These are people who in a general sense, own these individual areas. They're not normative. By all means, ask any of the TAs, including those not on the list, any question you like, email us, and either we will answer, regardless of the area, or we will forward it to the person who knows the answer. But these are general areas if you're interested. And there is a forum on Moodle, Ubiq support. We will make that active as soon as this session is over. Okay, getting the code. The code, we have a new page on Moodle for the code. There will be 2 links, so click on the little icons for the links. The Unity package is how you should deploy the code into your application, and you should keep it updated. So we will push you Unity packages that you can import. It's not in the Unity package manager. We looked into that. We tried to get it in. It's not going to be there, unfortunately, so you will need to download manually. We will upload the full source for everything, including the server, in this one. This is for reference, really. You feel free to run your own node server if you want to do development locally without going to our server. That's fine, but don't integrate any Unity code or build your project around the Unity code in this folder. Use the package. Okay, and we'll put notes and versions here so you can make sure you're on the latest. Okay, so that's the introduction. I'm going to hand over Felix for the last couple of minutes. You're just going to run through downloading the code and getting it into your project.
Yeah, actually, we're skipping the downloading stage because that takes too long.
Okay.
If you all of you would select my my picture, you would see my screen share. So I already downloaded it. If these are the 2 files that Sebastian pointed out, one of them will be yeah, it's not important that you can actually read it. Just follow along with the procedure. There will be 2 files. One will be just called Ubiq and a serial number, this is the Unity package. This is the one you will get if you click on Sebastian's page on the left icon. And the other one is the Git repository, that's Ubiq master. As Sebastian said, if it comes to Unity packages and using it in your project, use the first one. I'm about to show you how. So first step is to just unzip that. Then you get a folder which contains a few other folders and a few files. And then in the Unity project where you want to integrate it, and at the top you click on Window and then on Package Manager. Then there will be a new window opening, and in the top left corner will be a little plus. If you click on that, there's a context menu, and then it will give you 3 options how to open a package. We tried all 3, we could unfortunately only get one of them reliability work, which is the first one, add package from disk. And then you go to the file folder where you have extracted everything, and in it there will be a package JSON. This is the file that Unity wants. You select it, click open, and Unity will take over from here. You will get a few loading screens, and hopefully after a little bit of time, everything should be loaded. One thing noted, technically you can go into that folder and make changes to the file and through that to our package. However, because you're the only one who's having those changes, the same thing applies what Sebastian said, please don't do that, you will break stuff. Now that everything is over, you will see that we got an entry for this has still the old name, Sebastian, by the way. We probably should make an issue to change that. And you will see that there's a sample section down here. So far, we haven't imported any samples, so you will see that the asset folder, which you can't probably see because of the video quality or not correctly, looks still the same as before. If you need something like the prefab Sebastian has shown, you have to, in the tree down here, open the packages folder, and somewhere down there is an entry for UCLVE, which is Ubiq, and in there you'll find all the nice stuff. There's another way, if you just want a particular script and you have created an object, you can always use the search. That works too. Sebastian, give me a class.
As or Unity in general?
No, I mean something from Ubiq that you would attach to game objects.
A sample flare. Except for flair. No,
If that's in the samples,
Oh.
I can't give you it.
Oh, basketball. Oh, it's in sample. Well, you're meant to You're meant to subclass not subclass. Implement the interface UI components. Or game network object. Network game object.
Here we go. Network game object. And now it's attached. So, however, as I've already said, there are these samples, and Sebastian already showed you the Hello World sample. You probably want to start with something like that because you want to take a look at how it works. So you might be interested in this little button here that says import into project. This, again, takes a little moment. And then you will see that in your, still takes a little more moment, but in your assets folder, there's a new folder samples. And there's a new folder UCL CVE, a version number, and then you find the exact same sample folders that Sebastian showed you. So if you go into introduction, you will see our Hello World scenario over here. And if you're going into minimals, you will see under audio, the audio test example that Sebastian sent around last week. So feel free to roam around there and look at stuff. Some words of caution though. So someone brought up the question of updating. Unfortunately, that's not as easy as we thought. With all the official package, there's this little update button down here. Unfortunately, Unity has not implemented that yet for custom packages. So the current update process looks like that you will need to click on remove here and then add the new version again through the little plus in the corner and add package from disk. It's not ideal, but it will do the job. One thing of note, though, is that if you remove a package, the samples are not getting removed. So if you keep the old samples in and you have changed something in the newer version, which will also affect the old samples, you might get some error messages. Best way around that is delete the old samples, import the new samples. That's also why I would suggest that if you want to start off with a Hello World scene and then do changes to it to your liking, copy it out of the samples folder beforehand. Don't do it in the samples folder directly because, again, if you update, things will get messy because then you need to port it over in one way or another. All right.
Thank you very much, Felix. Okay, I've used all the time, so I'm going to stay around for a little while to answer questions if anyone has any. But other than that, thank you very much for attending, and let me know offline if there are any issues during the exercises.
Okay, and we'll just to thank you, Sebastian, and just to note that we will do that. The Wednesday session this week will be an interactive session for you to go through the examples and get help doing them. So we'll do what we usually do on Wednesday. We'll do what we usually do on Monday, which is split into different groups, and you can ask all the questions and go through and examples, and we can have different groups depending on your level of practice that you've done with the example before them.
For any problems or questions, should we post on the forum or send an email? Which do you prefer?
Shall I answer or you, Anthony?
You.
Okay. So whichever you prefer. Some people are comfortable posting in public. Some people prefer sending emails. What I will say is that it's always more helpful to, if you have a question, you're almost certainly not the only person. There's no such thing as a stupid question. So if you do post on the forum, other people benefit from it. What we might do is if there is a question that a lot of people are going to, we think a lot of people have, we'll copy your question in anonymously, maybe modify the text so it's very obviously not you, and answer publicly anyway. So really do whatever you prefer. The only downside of email is if one of us is away and you've emailed us alone, then you'll wait longer for a response.
Okay, I'm going to stop the recording there.